Welcome back to the workshop. This is Tim for Tim Krause Electronics, and you are watching part 4 of the $75 Dumble build series. Now, in the last video, we got the input FET stage assembled. We got that board installed. We got the relay board mostly assembled and installed. We got some LEDs put on the front panel and a few other things like that. And I also did the power supply for the first two tube filaments and everything downstream of there that's going to be run off of that same 12-volt supply. Unfortunately, I'm going to have to rebuild that because I realized that there is one major flaw in this design right now. Now, I took some measurements off of the secondaries of the power transformer, and I thought it was a little bit odd that the 12-volt supply was measuring 18.8 volts. And, I was thinking to myself, okay, well, there's no load on there right now, so once I put a little bit of a load on that circuit, the voltage will drop, hopefully to a safe level. I'll just take some measurements later when I get to that point. But here's the problem, and this comes from the fact that I've never dealt with DC filaments before. I've just never had a need to. I don't build a lot of super high gain amplifiers. And in most cases, let's say we're building a pedal that's designed to run on 9 volts. Well, if that voltage ends up being 12 volts instead of 9 volts, it's no big deal. It just means we've got a little extra headroom, and it's not going to affect anything. Same thing with tube plate voltage. If you're designing something assuming 300 volts and you end up at 320 volts, no big deal. As long as you're not exceeding that plate voltage, it's fine. And, the plates can run off of a pretty broad range of voltages. So I've never really had to think about that before. But it kept bothering me, and as I was doing the editing on the last video, it suddenly clicked in my head, and I realized I can't run anything. The 18.8 volts will fry those power tubes. I have to run those off of either 12.6 volts if I wire them in parallel like I'd planned on doing, or if I've got a 6.3 volt supply, that would work. But 18.8 volts is 1.5 times what I would need to run those tubes in parallel. So that and the phase inverter tube, those were all going to be run on, they would have ended up being run on 18.8 volts on the filaments, and that would have killed those tubes pretty quickly. So what I'm going to have to do is, at this point, I think it's safe to assume that since the Peavey Valveking didn't fry the tubes immediately, the way that they designed it brought the voltages down to a safe level, and because I don't have a lot of experience dealing with DC filament supplies, I'm going to build it exactly the way that Peavey did. So that means that the 12-volt DC supply is going to come before the power tubes, and all 5 tubes are going to be powered off of that DC voltage. I'm even using the same capacitor values that they used. Because I don't want to put myself in a situation where I unwittingly bring the voltage up a little bit higher than it ought to be and I end up frying the tubes again. So I've got to tear that power supply out. I've got to tear out the wiring that I put in on the filaments on the power tubes and completely redo that section. Hopefully that won't take too long. I don't think it's going to be difficult, but it also means finding a new spot for that power supply board. And I think I can fit that in behind that main circuit board, kind of in between there and the power tube sockets. So anyway, we're going to do that today. We're going to hook up all of the connections to that power supply, going to the relay board and then to the input board, and also all the LEDs that are being powered off of that. And I'll leave a little wire extra for the reverb and effects loop board, which are also going to be on the front panel of the amplifier now. Once all of that is done, then I can finally start wiring up the tube sockets. I can start bringing some wires from that from the core circuit board down to the tube socket pins. And at that point we'll be pretty close to having this finished and being able to take some measurements on the power supply. So let's go ahead and get started on that. Alright, so here's the board that I'm going to be using to build the new DC power supply for the filaments. And this is actually one that came out of the old build in this same chassis. This had some relays on it. and cleaned off as much of the solder as I could, and just rubbed some alcohol to get the flux off of there. I only had one spot where a pad lifted, but I think that's probably going to end up being cut off anyway, because I got to cut this board down to fit. And went and got some 2200 microfarad 35 volt caps. The schematic actually calls for two 1000 microfarad capacitors in parallel, and then a dropping resistor, and then another pair of those. So these will be close enough. And I have no layout drawn up for this, so I'm just kind of doing this off the top of my head. But man, the build cost of this just keeps creeping up slowly. Every time I make a mistake like this, I got to go out and buy a couple more parts. I didn't have these in stock. The only ones I had were 4700 microfarads. Anyway, let's get going on this. Now on the schematic, on the Peavey schematic, it shows a 1 ohm dropping resistor between these two capacitors. I'm hoping that's not a typo. 1 ohm seems awfully low for a dropping resistor, but I'm going to go with that and assume that it's correct. But I couldn't find a 1 ohm resistor, so I've got a 2.7 ohm resistor, and so hopefully this will be good enough. Alright, so that's ready for me to cut down to size. That resistor ended up a little closer to the capacitors than I would have liked, but you know, being only a 2.7 ohm resistor, I don't imagine it's going to be dissipating a lot of heat. So, but the schematic called for a 5 watt resistor, so that's what I'm using. Anyway, we'll find out when I have a chance to take some measurements. Okay, here's the 12 volt power supply board installed, and the next thing I need to do is I got to rebuild that rectifier board. Because I didn't wire that as a bridge rectifier, so I've got to fix that. Okay, so we've got the new rectifier board installed, and I'm not going to need to take this off again, so I'm going to solder in these high voltage secondary wires, and then I'll start working on rewiring these filaments. I'm running this shielded cable from V2 over to V1 because these filament wires are going to be really close to that main circuit board. This is why I wouldn't design something like this where the tubes are actually in the front of the chassis here. I would have them lined up all in back. But I got to work with what I've got here. Well, I obviously wasn't thinking when I put this relay board together, because these two wires off of both of these transistors are not necessary, because I've got these twisted pairs from the Cat5 cable that are going to be tied in there. And the control wire, which is going over to the switch, one of them is going down to this switch here, but the other one has to go all the way over here. And as you can see, that wire is not quite long enough. So I'm going to have to pull that out and put a longer one in there. This is one thing that's nice about working with double-sided boards, though. Okay, now we're ready to start connecting some wires to this circuit board. Well, I messed up on this layout. Right in here in this section where that notch filter is for the blues rock switch, I had a couple of these things connected in the wrong spots, and I almost got myself into trouble there because fortunately I was able to fix it from the top of the circuit board. But if I hadn't been able to do that, then I would have had to take this circuit board back out and fix it. And any of you that have worked on these amps know once you've got some tube sockets wired up, it is a lot of work to get the circuit board out, so I got lucky there. Well, that's where I'm going to stop for this video. Got all the tube sockets wired up, and I don't know if you noticed there at the end I had to switch to a solid core wire to wire up the grids for those power tubes. I just ran out of the wire that I had been using, so I'll have to order some more of that. The filament wires may end up being an issue. There are a couple of spots where other wires are crossing right over the filament wires, and with the amount of current going through there, that could cause an issue. So I may end up going back later and using the shielded cable again for the filament wire going from the phase inverter down to V2. And, you know, this is just another problem that comes from the way that Peavey designed this chassis, having the first two tube sockets mounted on the wrong side of the circuit board. It just complicates everything. Looking back, I probably should have just reused the holes that I made for the last build in this chassis. It would have meant that I would have had a little more difficulty getting that relay board in there, but you know, not more difficult than what I'm already dealing with now. But you know, it is what it is, so I'll keep working with this, and hopefully by the end we won't have any noise issues. Also, I don't know where I got this number from, but somehow I got it in my head that 18 gauge wire is only rated for 3.5 amps. And so that's why I've been using 18 gauge wire, because we're pulling a lot of current on this filament winding. And so I looked it up again, and it turns out that 18 gauge wire is rated for a whole lot more than that. In fact, 20 gauge wire would have given us a lot more than we need in terms of the current handling. So I could have used 20 gauge wire all along, and that would have been a lot easier to work with. The problem with 18 gauge wire, because it's so thick, first of all, it's hard to get two wires next to each other into a tube socket pin, which is something that you have to do. And also the 18 gauge wire doesn't bend as easily, doesn't stay where you put it, so 20 gauge wire would have been a lot easier to work with, so I'll keep that in mind for the next build. I have made up a chart, and I will make that available on my website, timkelectronics.com. There's a chart that shows how much current each wire gauge can handle, and even breaks it down between solid core and various stranded types. And then it's got several tubes, several tube types, most of the common tube types, and then some much less common tube types, and lists their current, their filament current demands. So, like I said, that'll be up on my website. I'm in the process of putting a new template up on that website, so I'm not sure if I'll be able to get to it right away, but I'll try and get it up there as soon as I can. The last thing I wanted to mention, the overdrive trim control, which is usually just a trim pot on the circuit board. Initially, I was going to have that on the front panel, and then I decided to put the effects loop jacks on the front panel instead. So, okay, I'll move the OD trim to the back panel. Well, now I've decided I don't like that idea, because that means running shielded cables from the front panel all the way to the back panel and then back up to the front panel. So instead, I'm going to mount it the way that Fender usually mounts their bias pots. So it'll have an adjustment. You'll be able to get to it outside the chassis, but it'll be underneath the chassis. I'll still have a knob on there, so you don't have to use a screwdriver or anything. But so I think that'll simplify some of the wiring a little bit. Next video, we're going to wire up all of the front panel controls. I may have a couple switches left to wire up, but all of the pots are going to be wired. And then I think that'll be enough for me to start taking some measurements on the power supply. So we're getting close. But anyway, that's it for this week's video. I'm going to get right into working on next week's video, so you'll see me with the same clothes on again. Like it if you like it, comment and subscribe, and we will see you in the next video.